Hello, good morning children. So let us continue the discussions with the polynomials part 4. So till now we have seen the different concepts in polynomials, values, zeros, then relationship between zeros and coefficients, geometrical representation. So just recollect the relationship between zeros and coefficients of linear polynomial, quadratic polynomial, cubic polynomial, etc. Now we move on to further discussion of polynomials, that is division algorithm of polynomials. So in the number system we have already studied about the division algorithm of numbers, and the same relation we are going to verify in the case of polynomials. Now just to recall the division algorithm concept of numbers. When you divide a number by another one, you can get a quotient and a remainder, and if the number is completely divisible by the divisor, then the remainder will be 0. So here also we can establish such a relation, and in number system we have the algorithm that dividend is equal to divisor into quotient plus the remainder. And let us consider the polynomial p of x. 4x cubed minus 7x squared plus 10x plus 10 by g of x equals 4x plus 1, where we take the polynomial p of x as the dividend polynomial and g of x as the divisor polynomial, and hence obtain the quotient and remainder. This is our topic. Now for division, before starting the division, you have to first check whether the two polynomials are in the standard form with all terms. See, p of x is a third degree polynomial, and see that all the terms are present. So there should be a third degree term, that is 4x cubed, then second degree term minus 7x squared, then first degree term 10x, and constant term 10. If at all any term is missing, you have to add there the 0 coefficient. Suppose that 10x was not there, first degree term was not there, so add the term 0x. So make the polynomial as complete, both the dividend polynomial as well as divider polynomial. You have to make them complete. That's the first step. And arrange in the standard form, descending powers of the variable. Now let us take the dividend polynomial divided by the divisor polynomial 4x plus 1. Just in the case of division of numbers we are following, but here only slight change is there. Now the dividend polynomial is 4x cubed minus 7x squared plus 10x plus 10 divided by divisor polynomial 4x plus 1. Now for the purpose of division, we are taking only the first terms. First term of the dividend polynomial is 4x cubed. That is to be divided with the first term of the divisor polynomial 4x. So with division you are not taking all these terms, you are taking only the first terms. First term of the dividend polynomial 4x cubed divided by 4x. So 4x cubed by 4x is x square. So that is the first quotient term. Now after getting the quotient, you have to multiply this x square with 4x plus 1. Now x square into 4x plus. So remember the multiplication. When you multiply a binomial with a monomial, you have to multiply each term of the binomial. So x square into 4x cube, then plus x square into 1, that is 4x cube, x square. Now subtract. As in the case of division of numbers, you subtract. Then 4x cube minus 4x cube is 0. And the second one is negative. Like terms, see that all the like terms are in the same column. So negative 7x squared minus x squared, minus 7 minus 1. So that gives minus 8x squared, and then write down the next two terms. So now the dividend polynomial has become negative 8x squared plus 10x plus 10. Then again follow the same procedure. First term of the dividend polynomial, that is minus 8x squared, divided with 4x. Minus 8x squared by 4x. That will give the quotient term negative 2x. So then again multiply negative 2x and 4x plus 1. So negative 2x into 4x is negative 8x squared. Then negative 2x into 1 is negative 2x. Now subtract like terms. This is 0. 10x minus negative. Change the sign and add. Change the sign of the second term and add with the first one. So 10x plus 2x, that is resulting in 12x. Then write down plus 10. Now can you divide it again? See, the degree of the dividend polynomial now is linear, that is first degree, and divisor polynomial was also first degree, so same degree, still you can divide. So 12x by 4x, you will get plus 3. Now multiply again, so 3 into 4x 12x plus 3 into 1 3, and subtract, and the remainder is 7. Now can you further divide? See, 7, can you divide 7 by 4x? The degree is less than the degree of the remainder. See, so here we cannot further divide. So always this remainder polynomial will have a degree less than that of the divisor polynomial. Then division is not possible. So this is your remainder. We cannot divide it completely with the 4x plus 1, and you get the remainder 7. And quotient is x square minus 2x plus 3. So this is the process of division of a polynomial with another one. So dividend polynomial was 4x cube minus 7x square plus 10x plus 10. And the divisor polynomial was g of x is 4x plus 1. You got the quotient q of x. Since it is quotient, you denote it by q of x square minus 2x plus 3. And since it is remainder, we denote it by r of x. All these are polynomials, so that is we are denoting it as r of x is equal to 7. Now we have to verify for the division algorithm for polynomials. So in the number system, you have verified it as divisor into quotient plus remainder. You should get back as dividend. So let us verify g of x divisor into quotient q of x plus r of x. Now divisor was 4x plus 1 into the whole into x square minus 2x plus 3 plus 7. And you know the multiplication of two binomials or trinomials, polynomials. So with each term of the first polynomial, you have to multiply each term of the second polynomial. So open the bracket. So 4x into x square, 4x cube, then 4x into minus 2x minus 8x square, 4x into 3, 12x. Then with the 1 you have to multiply 1 into x square, 1 into negative 2x minus 2x, 1 into 3, 3, plus the remainder 7. Now to simplify this one, there are like terms. So simplify the like terms and write it as 4x cube, there is only one term. Then minus 8x square plus x square is minus 7x square. Then 12x minus 2x is 10x plus 3 plus 7 is 10. So this is the answer. Now what was the dividend polynomial? You see, it was 4x cube minus 7x square plus 10x plus 10. Is it the same? Yes. So you can see that g of x into, that is divisor into quotient plus remainder, you get back 4x cube minus 7x square plus 10x plus 10, that is equal to the dividend. So this relation is true for polynomials also, that is dividend is equal to divisor into quotient plus remainder. The same relation existing in the case of numbers also valid for polynomials. So this relation is known as division algorithm of polynomials. So remember the division process and this division algorithm. Now you will have better analysis here. Now if a number 12 is divided by 4, you get 3 and the remainder is 0. Why you got the remainder 0? Because 4 was a factor of 12, so it is completely divisible. Here also two cases arises. One is the remainder can be 0, or else the degree of the remainder will be less than the degree of divisor. You have seen in the previous case, then when you divide it, you got remainder 7, and further division was not possible because the degree of this remainder was less than that of degree of the divisor. Divisor of first degree, and here the remainder you got 0 degree. So degree has gone down, so further you cannot divide. So either the remainder will be 0 or the degree of the remainder will be left divisor. So these two cases exist. Now we analyze the first one. You see, when the remainder is 0, when you divide with a polynomial with another one and you got the remainder is 0, then we can say that the divisor is a factor of the dividend polynomial. That is, gx will be a factor of P of x. Okay, and this is used for finding the zeros of higher order polynomials, because you have studied about the method of finding zeros of linear polynomial, quadratic polynomial by factorization, and cubic polynomial onwards. We will follow this method. Either you have to find a zero by trial and error method, or by some other given condition you will assume some, get some zeros, and the remaining zeros you will get by using this concept. Okay, now for example, you consider a question to find all zeros of the polynomial 2x cube minus 3x square minus 4x plus 2. See, this is a polynomial of which degree? There is third degree. So how many zeros can there be maximum? That is obviously 3, equal to the degree of the polynomial. If it is a third degree polynomial, there can be 3 zeros. Then it is given that x is equal to 2 is 1 zero of it. We proceed in the following way. So it is already given that x is equal to 2 is a zero of this polynomial. So how many zeros are remaining? 2 more. So that remaining zeros you have to find. Okay, let us proceed in this way. Now it is given that x is equal to 2 is a zero of the polynomial p of x, given by 2x cube minus 3x square minus 3x plus 2. We get, by factor theorem you have studied in class 9, if x is equal to a is a zero of a polynomial p of x, then p of a will be, remainder will be 0, and x minus a will be a factor of the polynomial. So using that concept, we get that x minus 2 is a factor of p of x. X is equal to 2, if it is a 0, then x minus 2 is a factor of p of x. Now we go for dividing the polynomial p of x by x minus 2. Why do we divide by x minus 2? See, you take the case of number system. Suppose you take 12. 12 is prime factorized as 2 into 2 into 3. 12 is equal to 2 into 2 into 3. So when you divide 12 by 3, you get the answer 4. Because when you divide 12 by 3, it is actually 2 into 2 into 3 divided by 3. 3 and 3 cancels. So when you divide a number with one of its factors, actually that factor from the number is removed. So the remaining will be the quotient. So likewise, to remove this factor, now our aim is to remove this factor x minus 2 from this polynomial p of x. So when you divide this third degree polynomial with the first degree polynomial x minus 2, you will get a quadratic polynomial, and that can be used for finding the remaining 2 zeros. Actually, we are removing this factor x minus 2 from this polynomial by dividing it. So whenever you are dividing a number by another number, we are actually removing that factor from it. The remaining you will get. So that is why next step is to divide the polynomial p of x by x minus 2. Now remember the process of division. So the quotient a dividend polynomial is 2x cube minus 3x square minus 3x plus 2, which is already complete in a standard form. Then divided by x minus 2. Process is the same. 2x cube by x, that is 2x square. Then multiply 2x square into x, 2x cube. Then minus 2 into 2x square minus 4x square. Now subtract. You get 2x cube minus 2x cube 0. Minus 3x square minus negative plus 4x square results in x square. Then write down minus 3x plus 2. Then again divide the first term by the first term of the divisor, because the degree of this is more than that of the degree of the divisor. So x square by x is x. X into x, x square, minus 2 into x, 2x. Again subtract. You get negative 3x, x square minus x square is 0. Negative 3x minus negative 2x. So it is negative 3x plus 2x, that is negative x. Write down plus 2. Now can you divide it again? Yes, it is same degree, so we can divide it once more. Minus x by x is minus 1. Multiply negative x plus 2. Remainder is 0. Why we got remainder 0? See, x minus 2 was a factor of it. That's why the remainder is 0. Okay, now we proceed in this way. Now by the division algorithm, you see the dividend polynomial 2x cube minus 3x square minus 3x plus 2 can be written as divisor x minus 2 into quotient 2x square plus x minus 1. The remainder is 0 plus 0. Okay, now the question reduces to the zeros of this polynomial is given by x minus 2 into 2x square plus x minus 1 is equal to 0. And from that, it's the product of two numbers is equal to 0 means each one can be 0. So x minus 2 is equal to 0 or 2x square plus x minus 1 is equal to 0. And x minus 2 is equal to 0 will give x is equal to 2, which was already given. So this is 1, 0. It was already given to you. And the remaining polynomial now exists as 2x square plus x minus 1 is equal to 0. Now this is a quadratic polynomial. To find the zeros of it, you factorize this one. 2x square plus x minus 1 factorize by splitting the middle term. See, middle term is plus x, so the coefficient is 1. So this is 1 is the sum of two numbers. A plus b is equal to 1, and a into b is 2 into negative 1 minus 2. So find out two numbers such that whose product is negative 2 and sum is positive 1. And there you can choose the numbers 2 and negative 1, because when you add 2 and negative 1 you will get to 1, and when you multiply 2 and negative 1 you will get to minus 2. So the numbers are 2 and 1. So the second term, middle term is splitted as, this x is splitted as 2x minus x. Then two terms are taken, and take the common factor from two terms by regrouping. So you get 2x into x plus 1. And from the third and fourth terms there is one negative sign common. So negative 1 into x plus 1. So that x plus 1 is a common factor now. So it is x plus 1 into 2x minus 1 is equal to 0. So here also two numbers product is 0. That means each one can be equal to 0. So x plus 1 is equal to 0 or 2x minus 1 is equal to 0. X plus 1 is equal to 0 means x is equal to negative 1 or x is equal to positive 1 by 2. So the three zeros of the given polynomial are negative 1, 1 by 2 and 2. 2 was already given to you. Okay, so this is how you find the higher zeros of the higher order polynomials. Okay. Now you can deal with another question. If the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, a and a plus b, find a and b. So here it is a third degree polynomial, and we are given that the three zeros are a minus b, a and a plus b, where a and b are arbitrary constants, real numbers. So we are asked to find a and b here. Okay. Now by the relation you see, alpha is equal to, let us call them as alpha, beta, gamma. There are three zeros, so we can call it as alpha is equal to a minus b, beta is equal to a, and gamma is equal to a plus b. They are the zeros of this given polynomial. Now we have three relations for a third degree polynomial, cubic polynomial. Sum of the zeros, alpha plus beta plus gamma, there is negative b by a. And this b and a are known to us because the polynomial is already given, ax cube plus bx square plus cx plus d. So we have the values of a and b. So it is positive 3 by 1. So alpha plus beta plus gamma is 3. And alpha is a minus b, beta is a, and gamma is taken as a plus b. So a minus b plus a plus b is equal to 3. And from that, minus b and b cancels, so you'll get a plus a plus a, 3a. 3a is equal to 3, so that a is equal to 1. So the value of a already got. Now there are two more relations. Next one is alpha beta plus beta gamma plus alpha gamma is equal to c by a, where c was quotient of x, that is 1 by 1, 1. And alpha beta plus beta gamma plus alpha gamma, you can substitute the value, that is a minus b into a minus b, alpha into beta. Beta is a, alpha is a minus b, so a into a minus b, plus beta gamma, a into a plus b, plus alpha gamma, a minus b into a plus b, that is equal to 1. C by a is 1. So you get another equation where the value of a was already calculated. So a was 1. So put the value there. So 1 into 1 minus b plus 1 into 1 plus b plus 1 minus b into 1 plus b is equal to 1. So this is an equation having only b. So rewriting it, opening the bracket, simplifying, you will get 1 minus b plus 1 into 1 plus b, 1 plus b plus, this is of the form a minus b into a plus b, that is a square minus b square, or 1 minus b square is equal to 1. Simplifying, 1 plus 1 plus 1, 3, minus b and plus b cancels, you will get minus b square. So 3 minus b square is equal to 1, or minus b square. You take this 3 to the right side, you will get negative 2. So minus b square is equal to minus 2, b square is equal to positive 2. Now this is b square, we need to get the value of b. So from an equation of second degree, suppose x square is equal to 9. Taking square root on both sides, you will get x is equal to plus or minus 3. So whenever you are taking square root from a square equation, you need to put plus or minus. Both the values can be satisfied. So plus root 2 and minus root 2 are satisfying this condition. So b is equal to plus or minus square root of 2. So the values of a and b are a is equal to 1, b has two values, plus root 2 and minus root 2. So this is how you solve it. Okay. Now we go for NCERT textbook exercise 2.3 questions 3, 4 and 5. Try to do this one, and if at all you are having any difficulty,